Ladies and gentlemen, we are on the second question. Here is already a Turkish version you can reach. Okay, here it is. The question asked in the summer school a few years ago. Here is the Turkish version. You can find the solution on my webpage. So let's read and try to solve. Time is getting consumed. Let's get faster. Let me clean this guy. Let me clean. At least possibly some part. Okay, let me delete all of them. Okay, let's read and try to understand what the question asks. A delta connected, beep beep, delta, take care. Round rotor synchronous generator is operated on a three-phase grid. Here's a three-phase grid, three cables. Here's infinite bus, I mean three-phase grid. Sometimes we represent three-phase by 3 phi or 3 tilde. All those mean alternating phase. Three-phase and three-phase. Here's a three-phase grid. Our generator is possibly supplying the grid. It is operating on grid. It is operated on such a grid. Three-phase 400 volts. 400 volts. Phase to phase. Line to line. I mean line to line. Between phases. And supplies 80 amps. Houston, there's a line current which is 8 amps, having a power factor of 0.8 lagging. Power factor of 0.8 lagging. Yes, okay, it looks clear, everything is clear. Let me take notes. Line to line voltage is 400 volts. I skipped the units. It is delta connected. Since it is delta connected, single phase voltage is equal to line voltage, which is 400 volts. Line current is given in the question as 80 amps. Since it is delta connected, single phase current is equal to line current over square root of 3. That's it. Those are the given parameters. And one more. Power factor is 0.8. I mean phase displacement is equal to arc cosine power factor, and phase displacement is such a radians. That is the angle between voltage and current. And let's interpret it in degrees. Convert it into degrees by multiplying such a coefficient. That is the phase displacement, Houston, in degrees. Let's control the polarity or sign of the phase angle. Houston, take care. It is lagging. Lagging. Lagging means phase angle is negative. Let's make a correction. Let's make a correction. phase angle must be negative. Here in this case, we have just interpreted it from the given operating condition, lagging. Since it is lagging, phase angle must be negative, and we have made the corrections. And keep reading. No load voltage of single phase winding of the generator is set to 500 volts. What does it mean? Here's a single phase. What the single phase? Okay. You remember equivalent circuit was drawn for single phase, and here is a terminal, single phase terminals, and assume that generator delivers no current, no load. In such a case, terminal voltage is equal to no load voltage. Ta-da! Here's no voltage change across those elements, so EMF will be equal to that voltage, which is given in the question as 500 volts. Houston, single phase voltage is given in the question, and it means that magnitude of EMF is 500 volts. It is a hidden parameter given in the question. Here it is, and it is kept constant. Houston, it is kept constant. Let's write magnitude of EF is equal to 500 volts. It is a single phase voltage EMF, and it is kept constant during the operation. He says it is kept constant. Okay, in the first question, calculate the active and reactive powers. It is very easy. Let me just discuss on the answer sheet. I hope it is somewhere here. No, okay, let's calculate. It is not here. Active and reactive powers. P and Q are asked. Ladies and gentlemen, current is known. Current is known. Terminal voltage is known, line to line. So by multiplying square root 3, you got three-phase apparent power, and then if you multiply apparent power by power factor, you got active power. If you multiply apparent power by sine phi, you got reactive power. Let's do it. Apparent power for three-phase circuitry is equal to root 3 times line to line voltage times line current given in the question. Every parameter is known, so result is this volt amperes in terms of volt amperes. Now let's calculate active power. Active power is equal to apparent power times power factor or cosine phi. That is the active power in terms of watts. And let's calculate reactive power. It is equal to Houston apparent power times sine phi phase displacement. It is equal to something negative. Is it correct? Houston, lagging. Houston, somewhere Hoca said lagging reactive power, lagging phase displacement, reactive power must be positive due to complex conjugate operation. So there is something need to be corrected. So due to complex conjugate, I write here negative, so I made a correction. That is the volt-ampere reactives. Volt-ampere reactives. That is the reactive power, and we got the result. That is the result. 44 kilowatts, 33 kilovolt ampere reactives. That's the solution of the first part. As a second part, let's continue. Calculate the synchronous reactance of the generator. Calculate the synchronous reactance of the generator. Here would be 4 different approaches to calculate the result. Let me show by using answer sheet. In the question B, synchronous reactance is asked, excess is not given and need to be found. But as explained in the answer sheet given in Turkish and English, you can find in my webpage, there are 4 different ways, approaches. One is from phasor diagram, using phasor diagram. The other is using inner power balance. The other is using reactive power balance. And the last one is using Kirchhoff's voltage law around loop, and it gets to phasor diagram. It gets the same equation effect, result in the same equation. So there are lots of approaches. Sometimes it is complicated. It depends you. So this is a difficult question, as I said earlier. I prefer the second approach here, since due to time consideration. Let's read the question again. A delta connected round rotor generator is operated blah blah. No load voltage. Something has missed in the question, not given. Possibly, perhaps in Turkish version, I have missed something. Possibly edit later. Resistance of armature must be given in the question. It is not mentioned, I think, here. So in English, here in the question, array is neglected. Omitted. Array is omitted. It is given in the question. Assume that it is given. So if you do that, if array is neglected, there is no copper loss in armature. That means converted electric power not lost here in copper loss and delivered to grid, and it is already calculated a few minutes ago. We have already calculated. It was something like that. Okay, 44 blah blah kilowatts, and it is equal to this guy. How can I solve this problem? Okay, let's use the method. Input inner power, induced power, can be written as 3 times EF times current times cosine PC. That was the inner power angle. Inner power angle. You should find this, define this, and you know this. Let me. You know this. You know this. But you don't know psi. Possibly, you know EF. Yes, you know EF. You know EF. It's kept constant. It's kept constant during the operation. So, you know EF. You know I1. It is given as I1 line given as 80 amps. It is star connected. It is equal to I1. You know this. So, psi can be calculated from this equation. Psi I have calculated such a radian or degrees, but I don't deal with sign of the psi. Let's check it out. What does psi mean? Machine is operated as a generator, so delta is positive. That is the counterclockwise rotation, which is positive rotation. And in the question, current was lagging. Here is a negative phase displacement. So phase displacement between EMF to current is psi, inner power angle. So we know the phase displacement 0.8. It was 37, something like that. Here it is, and we have just calculated psi. So that is 50 approximately. That is 37 approximately. So this guy delta is 13 degrees. Can easily be deduced from the phasor diagram. I recommend you draw phasor diagram. When you got this, you can substitute it here. You know it, EMF, it was 500 volts. You know voltage, it is given 400 over root 3. It was, I think, here it is. Houston. Let's read it again. I am not sure. Delta and star get confused. It is delta connected, so V1 is equal to V1 line. It is 400 volts. But line current, somewhere here I written wrong. I1 is equal to I1 line over root 3 because it is delta connected. Okay, and then let's substitute them. Here is the 44 blah 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 kilowatts, and as a result excess can easily be calculated, but the solution and the parameter is very hidden, so the solution is not easy. There are 4 different approaches, as I said. I have used the easiest one here. There are some other methods you can follow here. That was the solution of third one. Second one, synchronous reactance is found right now. It was 3 blah blah ohms. Calculate the load angle of the generator. Now, as you see, machine is delivering some active power and some reactive power, lagging reactive power. And then here is some delta. I don't know, but let's calculate. It looks easy. It looks easy because we know 3, we know V1, we know EF kept constant at its initial value. We know the second case delta, beep, beep, beep. No, we don't know because delta is asked right now. We don't know delta. We know power, which was 44 kilowatts, something like that. Houston, here it was. The time is about to be consumed. There is only 1 minute behind. So, known only one parameter unknown, which is delta nu. Delta, not nu. There's only one delta in the question. So delta is such a radian and 13.3 degrees, leading, positive and leading. Ladies and gentlemen, because machine is operated as a generator, it must be positive.